Hey guys, so let's go ahead and look at section 1, topic 6, which deals with radicals, which is kind of an extension on exponents. So remember, a radical is any sort of root, so square root, cube root, fourth root, fifth root. So if we look at this first one, we're trying to decide what root we can take of this expression to end up with that if we simplify it. The first thing I would look at is our variable. So we started with x to the 6, and then we took some root and got x squared. So remember, if we have an exponent, we want to divide by some number to get our answer outside the radical. So 6 divided by what number would give us 2? Well, that would be 3. Same thing with the 12. 12 divided by 3 would give us that y to the 4th. And then if we're talking about 54, remember we're taking the cube root. So a perfect cube that goes into 54 is 27. And we want to multiply that by 2. And remember that the cube root of 2 we can't simplify, but we can simplify this cube root of 27, which is 3, and that's where that 3 comes from out in front. Okay, number 3, write an equivalent expression with a rational exponent. So that just means a fractional exponent. So if you don't remember, if we have something like the cube root of x to the 4th, the exponent is going to go in the top of our fraction, and the root is going to go in the bottom of our fraction. And if we can simplify that fraction at any time, we want to try and do that. So we have 8th root of 5 to the 6th power. So we want to rewrite this as a fraction, but we can simplify that 6/8 to 3/4. And that's it. That's all we can do to simplify it. Now, this next one, x to the 2/3, and the 4th root of that would be 2/3 divided by 4. So if we're going to write that out here, 2/3 divided by 4 over 1. Remember, when we divide fractions, we want to multiply by the reciprocal. So 2/3 times 1/4 would be 2 over 12, which would also simplify to 1/6. So that would be x to the 1/6 power. And then the last one, we want to first simplify what's inside the parentheses. So I'm going to go ahead and change this outside to 8 to the 1/3, because the 8 is to the 1st power right now. And then we have the square root of 8 squared is 64 plus 64. Excuse me. And we can go ahead and add those together. So we have 8 to the 1/3, and then 64 and 64 would give us 128 to the 1/2 power. Now, firstly, 8 to the 1/3 power, that's the same thing as the cube root of 8, which is just 2. And then the 128 to the 1/2, I'm just going to leave that like it is. And that's as simple as we can get that. Okay, number 3, so we want to know which one of these is equivalent to x to the 7/4 power. So x to the 7/4, remember we wanted to do power over root. So the exponent over the index of the root. So if we rewrite this first one, that would be x to the 4/7, which is not the same. This one would be x to the 7/4. So we're going to select yes for that one. The third one is the same thing, x to the 7/4. It's still an exponent, even though it's outside those parentheses. This one is not going to be the same because it's not just x to the 7/4. We're then taking the square root, and it's not going to be the same if we're taking the square root of it. This one, let's rewrite both of them as rational exponents. So x to the 5/4 times x to the 2/4. And if we add those exponents, we're adding fractions. So 5 plus 2 would give us x to the 7/4. Let's look at this one. So we have x to the 4/5 times x to the 4/2. And if we were to add those together, we would not get 7/4. We would get something different. Let's make sure what that is. So 10 would be our common denominators. So that would be 8 over 10 plus 20 over 10. 28 over 10 is not going to simplify to 7/4. And then the last one, remember I said in the previous video, everything raised to the 0 power is, so we're just left with the 4th to the 7th power, which we did say up there, does simplify to x to the 7/4. So the second, the third, and the last one were all correct. The other three were not. Okay, and then the last problem I want to look at is number 7. So number 7, it does look like a lot of work, but we want to first simplify as much inside those parentheses that we can. That's going to make our a lot easier. So remember, we're raising everything on the left to the 1/2. So 512 is a perfect cubic root. The cubic root of 512. If you don't have your list of perfect squares or cubes, you can always use your phone or look it up on the internet. Just look up list of perfect squares, list of perfect cubes to get those numbers that we had in class. And then if we're taking the cube root of x to the 6th, we're going to divide. So 6 divided by 3 would give us x squared. 9 divided by 3 would give us y to the 3rd. And then in the bottom, we're taking square root. So the square root of 16 is 4. The square root of x to the 4th. Technically, this has a 2 index. So 4 divided by 2 would be x to the 2nd power. And 6 divided by 2 would be y to the 3rd power. And you'll notice that the variables are all the same. So we want to simplify this with 8 divided by 4, which would just leave us with 2 to the 1/2. And is that equal to the square root of 2? Well, let's rewrite this. So exponent of 1, index of 2 does end up being the same thing. Again, if I didn't go over a problem you had a question on, don't hesitate to message me on Remind or email, and I'll get back to you. Thanks, guys.